So, a very typical combination or permutation problem about probability in section B. And then there are 21 boys, 11 girls, and then we are going to choose 5 students in total. And then we want to know how many different committees can be formed if there are at least one boy. So, we try to list out all the possible outcomes before we start our calculation. The first situation is we have 0 boy, all girls, and then 1 to 4, 2 to 3, 3 to 2, 4 to 1, 5 to 0. What we concerning is the combination of at least one boy. That means 1 to 5 are all acceptable. Only the first one we don't accept it. So you may choose to calculate these 5 terms one by one, or a more simplified method is 1 all possibility, exclude the only one that you don't want. If I use this method, then you may write down the required probability is equal to 1, and then subtract the situation that we have 0 boy and all 5 girls. But hold on, they're asking you how many different committees can be formed. We expect some integer. You don't need to divide by the total possible outcome. So this is totally wrong. Don't make this kind of mistake again. And then you should write down the number of different committees. With at least one boy is equal to all possibility, and then minus the target, which is 0 boy and 5 girls. We have among all students, we have 32 students in total. We are going to choose 5. This is the number of combination without any constraint. And then we have to exclude the only case that we don't accept. Among 21 boys, we choose none of them. And at the same time, among 11 girls, we choose all of them. So this is 200914. Then you already solved this question with get 3 marks in section B. Of course, some of you may not realize that you can use this shortcut. Maybe you want to calculate one by one, case by case here. It's totally fine. If you try to do so, the number is equal to among 21 boys we choose 1, among 11 girls we choose 4. Another situation, among 21 boys we choose 2, 11 girls we choose 3, 11 boys we choose 3. 11 girls we choose 2. 21 boys we choose 4, and then 11 girls we choose 1. Finally, 21 boys we choose 5, and then 11 girls we choose none of them. You also get the same answer. Even though this is a very stupid method to get the answer, but it gives you different approach to calculate the same values. And then it's good to check your answer. If you find that 2 values are not the same, then you better think carefully which one should be correct.